Okay, so this is lesson 15, another form of the equation for a linear relation. So lesson 14 was on linear relations, but here's the thing. They're not always given to you in that form. Like slope-intercept form is what we did in 14. That's y equals mx plus b. But sometimes they're given to you in different forms. For instance, they could be given to you in what's called general form, which is ax plus by plus c equals 0. So everything's been kind of mixed up, and it's all on the left-hand side equal to 0. So what you can do is you can take general form and change it to slope-intercept form. So the key is y has to be by itself. Okay, so let's take a look at this. So 3x minus y minus 5 equals 0. First thing we're going to do, we're going to get rid of the whole positive 3x. So to get rid of the positive 3x, we subtract 3x from both sides, and that'll move it to the other side. So we end up with negative y minus 5 equals negative 3x. Okay, getting better. Now we got to try to get y by itself, so we have a negative 5 there. How do we get rid of that negative 5? Well, we add 5 to both sides. So we add 5, those are gone. So we end up with negative y equals negative 3x plus 5. Well, hey, that's already in y equals mx plus b form. No, it's not. Y needs to be positive for this to work. So what we can do is you can take this whole equation and multiply it by negative 1. So negative y times negative 1 will end up with positive y. Negative 3x times negative 1 is positive 3x, and positive 5 times negative 1 is negative 5. So there. So what we've done is we've taken 3x minus y minus 5 equals 0, rearranged it all into slope-intercept form, so it ends up being y equals 3x minus 5. And then you can graph it like you normally would, right? The y-intercept is negative 5, the slope is 3, which means we go up 3 and over 1, or you could do it with the table of values. Okay, flip to the second page now. So here we go. Sometimes you'll get a question where they don't give you the equation, they give you some words, and you got to turn it into an equation. So two integers have a sum of 3. Okay, two integers. What should we call them? Hey, let's call them x and y. Why not? So what we can do is x plus y equals 3, sum of 3. Write an equation to help us find the solutions. Again, we want to get this into slope-intercept form, so let's rearrange it. So we want y by itself, so we got to get rid of this. So we got to rearrange this. So what we're going to do is we're going to take x from both sides. So minus x minus x. So it goes y equals negative x plus 3. Well, great. Now it's in slope-intercept form. So you can do it one of two ways. You could see that the y-intercept is 3. The slope, hey, that's negative x, which means negative 1 over 1, which means we go down 1 over 1, down 1 over 1. Or if you wanted to, you could grab and do a table of values. So x and y, pick some values of x, 0, 1, negative 1. Doesn't matter what you pick, just make sure they're nice numbers. Plug them into the equation. We end up with 3, 2, and 4, right? We just plug them in. So we could graph those points. So 0, 3, 1, 2, negative 1, 4. There's our line there. Easy way. Okay, go to the third page. So now, what if we have x plus y equals 3? And what if x wasn't there? It's just a different form of an equation. So x is not there, so we basically get rid of it. So we just have y equals 3. So in this case, what is y always equal? Y equals 3. So pick some values of x. There they are, 0, 1, negative 1. What is y in every single one of these cases? 3, 3, and 3. So let's plot those points and see what we get. So 0, 3, 1, 3, negative 1, 3. Well, that's interesting. It forms a perfectly horizontal line. Okay, so horizontal lines always have the equation y equals something, whatever it happens to be. So for instance, if I had y equals negative 5, you'd have a horizontal line at negative 5. If I had y equals 10, you'd have a horizontal line at y equals 10. Horizontal lines are always in the form y equals. All right, page 4. What if y wasn't there? So we're taking the original equation and we're changing. So y is gone. So we just end up with x equals 3. So in every single one of these cases, x equals 3. Well, okay. So you have to pick different values of y this time. So 0, 1, and negative 1. What does x equal? 3, 3, 3. Okay, so 3, 0, 3, 1, 3, negative 1. If you plot all those points, oh, look, they form a perfectly vertical line. Okay, so here's our equation now, or rule now. Vertical lines have the equation x equals whatever it happens to be. So, for instance, if I said x equals negative 4, you'd have a vertical line at negative 4. If I said x equals 8, you'd have a vertical line at 8. So, x in the form of x equals, you have a vertical line. Okay, page 5. We've already talked a little bit about positive and negative slopes. This is just a refresher in this case. So, when you have a positive slope, you're always talking about whatever point you pick, you go up and to the right. Positive slopes are up and to the right. Negative slopes, you take the point on the left here and you go down and to the right. If you notice, everything is always to the right. So if I said I have a slope of 7, you would go up 7 over 1. If I said I had a slope of 3/4, you would go up 3 over 4. If I had a negative slope, let's say negative 5, I would go down 5 over 1. If I had negative 1/3, I would have down 1 over 3, right? The slope, if it's in fractional form, is really, really easy. If it's a whole number, or sorry, if it's an integer, then you always have to put it over 1. Okay, last page here, page number 6. Let's talk about this one. So we got 3x minus 2y equals 6. And this one, it says sketch using specific x values. So what we can do is let's do both. And we can do a table of values, and we can also rearrange it into an equation here. So 3x minus 2y equals 6. Okay, so let's start by plugging in numbers. So we're going to plug in x equals 4. Okay, so 3 times 4 minus 2y equals 6. 3 times 4 is 12. Minus 2y equals 6. We're going to solve for y. We're still trying to do it. We have positive 12. How do we get rid of it? Negative 12. Subtract 12 from both sides. So we end up with negative 2y equals negative 6. How do we get y by itself? Divide by negative 2, negative 2. We end up with y equals 3. Oh, okay, so there's our first point. Y, comma, 3. Let's try the second point, and we do it down here. We're going to plug in 0 this time. So 3x minus 2y equals 6. Plug in 0. 3 times 0 is 0, so that just completely disappears. We end up with negative 2y equals 6. Divide both sides by negative 2. We end up with y equals 3. So back up here, we have 4, 3. That was the first one. 0, negative 3 is our second one. Now we still got one more to do. We have negative 4. We're going to go down here and plug in negative 4. So 3x minus 2y equals 6. We just plug in negative 4. 3 times negative 4 is negative 12. How do we get rid of the negative 12? Add 12 to both sides. So negative 2y equals 18. Divide both sides by negative 2 because we want y by itself, and negative 2 is multiplied by it. So we end up with y equals negative 9. And then we get negative 4, negative 9. So let's plot them. So 4, comma 3. 1, 2, 3, 4, comma 3, right there. Remember, always start at the origin, do your x's first, positive to the right, negative to the left, and then do your y's, positive up, negative down. The next point is 0, comma, negative 3. So 0, we don't go anywhere with the x, we just go straight down to negative 3. And negative 4, negative 9, we start at the origin, we go over 1, 2, 3, 4, that's negative 4, and then down negative 9. And again, you know you did the math correctly if those 3 points line up. Now, if you only pick 2 points, you wouldn't know if you did it correctly. But 3 points will always line up in a perfect line if you've done the math correctly. Okay, so that was lesson 15. Now you can work on practice 15.